Gear-based continuously engaged variable transmission, GCEVT. Gear shift demonstration. Down gear shift, up gear shift. This presentation presents the personal views of the inventor, aims of the invention for both electric and motor vehicles, improve fuel economy and decrease CO2 emissions, improve performance, improve safety, decrease wear and tear. GCEVT basic characteristics. Continuously engaged transferring power at all times, including the phase of gear ratio change, unlike most other transmissions. Continuously engaged through gears, unlike the CVT. Clutches and torque converters not needed. Being gear-based, it can provide exact gear ratios and can therefore be coupled with a differential assembly to provide exact, absolute zero motion, a feature very useful for all vehicles, especially electric and hybrid. Advantages of a transmission with the characteristics of the GCEVT for all vehicles. The gear ratio can be kept at the optimum ratio constantly, offering the highest torque or the highest economy throughout the journey depending on the needs. The zero motion embodiment enables the engine to be running at any speed while the wheels are kept stationary by the transmission. The vehicle can launch by going into gear. A racing vehicle can launch while the engine is running at maximum torque. A family vehicle can launch uphill with no need for use of a handbrake. For electric and hybrid vehicles, each time before the vehicle launches, the motor can be revved to the appropriate revolutions with no load to minimize the initial loss of energy into the motor as heat caused by inrush current. During travel downhill or during braking, the gear ratio can be changed appropriately while the motor is engaged to the wheels, forcing the motor to rotate at the required much higher speed, thus acting as a dynamo, thus storing electrical energy into the batteries while at the same time decelerating the vehicle at the desired rate. All this translates to greater vehicle autonomy, i.e. more kilometers or miles per charge, more kilometers or miles on the same battery, and, optionally, a smaller battery for the same kilometers, and a smaller motor for the same acceleration and deceleration. This presentation consists of three sections: basic principles, alternative embodiments, detailed description of the principles of the invention. Basic principles. This is a very basic prototype built with sole purpose to demonstrate the main principles of this invention. It represents one of countless possible embodiments, and only 4 composite gears are used, just enough to demonstrate the key features of the invention. This is a diagram representing the embodiment of the invention seen in the prototype. The composite gears are numbered 1 to 4. A differential assembly is included for the zero motion embodiment. Demonstration of gear positions in the simple and in the differential version of the GCEVT. This device demonstrates 2 embodiments of the GCEVT, the simple and the differential. In the simple embodiment, this is the input gear, this is the central gear, and that is the output gear. In the differential embodiment, a differential assembly is included in the device. And in the differential embodiment, this is the input gear still, this is still the central gear. This, however, is not the output gear. Instead, it is an intermediate gear, and the output gear is the crown wheel of the differential assembly. In the simple embodiment, when the input gear is on the 4th ring, the output gear is on the 1st ring, and this represents the 1st gear. In the differential embodiment, this represents the rear gear. Notice that the crown wheel of the differential is rotating slowly in the clockwise direction. When the input gear is on the third ring, the output gear is on the second ring, and in the simple version this represents second gear, while in the differential version this represents the zero position. In this position, the output gear remains stationary irrespective of the speed of rotation of the input gear. If this were the transmission of a motor vehicle, this means that the car engine would be running at any speed, while the wheels would be kept stationary by the transmission, ready for vehicle launch. When the input gear is on the second ring, the output gear is on the third ring, and in the simple version this represents third gear, while in the differential version this represents the first forward gear. Notice that the crown wheel of the differential is rotating slowly in the counterclockwise direction. When the input gear is on the first ring, the output gear is on the fourth ring, and in the simple version this represents the fourth gear, while in the differential version this represents the second forward gear. Notice that the crown wheel of the differential is rotating in the counterclockwise direction faster. Alternative embodiments. The invention is very flexible and versatile, allowing for a multiplicity of alternative embodiments for full industrial development. Detailed description of the principles of the invention. Basic idea. First, have a look at a gear rotating through half a cycle around another gear. We need the blue gear to shift from the smaller to the larger yellow gear while rotating. Have a look at this for up gear shift. For down gear shift, the blue gear has to shift from the larger to the smaller yellow gear while rotating. Let us go through the process of up gear shift step by step. While the complementary blue gear is rotating around composite gear A, the yellow gear, the displaceable parts are displaced along the line of best alignment, so that by the time the complementary gear would disengage the displaceable part of composite gear A, it would be functionally aligned to the body of composite gear B. While rotation continues, the displaceable parts are displaced back along the line of best alignment until they reach their original positions. Further explanation. In this figure, the displaceable parts have been totally detached to demonstrate the shape of the composite gears. The displaceable parts should have such a shape that allows them to be displaced along the line of best alignment as shown. The diagram on the left demonstrates the alignment of teeth of the composite gears in the central gear used as a demonstration in this presentation. Each composite gear differs from the one next to it by 2 gear teeth, which creates 2 lines of best alignment. Only 4 gears were used, just enough to demonstrate all the features of the invention. Gear shift demonstration with detailed explanation of the process. For this demonstration, this is the input gear, that is the central gear, and that is the output gear. On the central gear, we have got the composite gears, 1, 2, 3, 4, and for the sake of simplicity, we shall refer to them as rings. This central gear comprises 2 elevators. An active elevator, which is now situated on the top of the central gear, which also possesses a pointed extension, and a passive elevator that is now situated at the bottom of the central gear, which does not possess a pointed extension. The construction of the assembly is such that as the pointed extension and the active elevator are pushed towards the narrower part of the central gear, the passive elevator is pulled towards the wider part of the central gear. We will now demonstrate down gear shift. Notice that we start with the input gear engaged to the second ring and the output gear to the third ring on the central gear. During down gear shift, the gear change handle is pushed upwards. This displaces the upper tilted disc outwards, which in turn intercepts the pointed extension on the active elevator. As rotation continues further, the pointed extension and the active elevator are displaced towards the narrower part of the central gear. And as rotation continues further, the input gear, which was engaged to the second ring, comes to engage the third ring on the active elevator. As rotation continues further, they are both displaced towards the wider part of the central gear, and therefore we end up with the input gear engaged to the third ring and the output gear, which was on the third ring, engaged to the second ring on the central gear. We will now demonstrate up gear shift. Notice that we start with the input gear engaged to the third ring and the output gear to the second ring on the central gear. During up gear shift, the gear change handle is pushed downwards. Therefore, on this occasion, it is the lower tilted disc that engages the pointed extension of the active elevator, and as the rotation continues further and the active elevator is displaced towards the narrower part of the central gear through the action of this rod here, the passive elevator is displaced towards the wider part of the central gear. As rotation continues further, the input gear, which was engaged to the third ring, comes to engage the second ring on the passive elevator. As rotation continues further, they are both displaced towards the narrower part of the central gear, and we end up with the input gear, which was on the third ring, to be engaged to the second ring, and the output gear, which was on the second ring, to be engaged to the third ring on the central gear. Down gear shift, up gear shift.